Good day guys, I'm Jemo and this is part 2 of my video blog about the custom gearbox that I designed, which is intended for combat robotics use. First off, what is the gearbox for? To simply put it, the power that's available from the motor is translated to become an effective driving force for the machine through this output shaft by increasing the torque through the gearbox. So that is the main function of this gearbox. My reference for this design is from two tried and tested products that is widely used in the field of combat robotics. One is the ampflow reducer and the other one is the Team Wayachi M3 gearbox. The ampflow reducer has an 8.3:1 reduction ratio, and the Team Wayachi gearbox has a 7.1 reduction ratio. So I assumed that range is the effective working range in designing for a speed reducer. So after putting all together the parts and coming up with the ideal working size, mine ended up with a 7.2:1 reduction ratio. Similar to the two brands I mentioned, I designed this gearbox to fit with the 3-inch ampflow motors. Ampflow brand motors is widely used in the field of combat robotics. This is an example of a 3-inch ampflow motor. This is an E3400 and I will couple it with this gearbox, and this set will be used to drive the middleweight combat robot that I'm currently working on. So I just have to remove the pulley and replace it with the pinion gear, and I can couple it with this gearbox, and it's ready to use for the robot. Now about the problems I mentioned in my previous video. The orientation of the gear from the initial assembly were incorrect. These gears, they have little boss spacers to keep it away from the walls, but since it was inverted, instead of having clearance here, they were flat scratching on the surface. Now I have corrected the orientation, so you can see there are clearances from the sides. I removed these end blocks. It's supposed to be here because after 3 nights of tweaking on this thing, I sorted out that this is the suitable working clearance, and as you can see, this now ended up too narrow. What happened here? Probably during the design process, I was too conservative with the clearances. So if I will insist on using this, I end up compressing it this way, and it's compressed too much to the point that you can't rotate it anymore. It gets stuck up. It's workable. I just have to use shim plates that will fit in here to make it work. This secondary assembly, this needs some more work and attention because it gets tight at certain positions sometimes. But I guess it's more of just an alignment issues. At the moment, I can't mount this motor to this gearbox because I'm still waiting for the bolts that I bought online, because these threaded holes, these are in inches, so these are not available in where I am at right now, so I bought it online. So we'll just save that test for the next video. Well, that's all for now, and thanks for watching, and please subscribe to my channel. Thanks, and God bless you all.